Hey there.
Yeah, I don't know what's up with my video. Sorry, Dan.
Who is it?
This is Michael Allen from Washington State University.
Oh, okay. Yeah, I could not tell from your video.
Yeah, no kidding. It's supposed to be, this is my, there's my face.
Okay, okay, yeah, I get it now.
Yeah, I don't know what's wrong. I've been testing, I've been dialing in the last 2 weeks, and I thought, oh, well, let's try and get Zoom installed and running on Linux, which took a little while, but I did it.
Oh,
And
well,
now I tested
maybe
the
you did.
webcam.
Yeah,
I tested
okay.
the webcam with Skype,
It's
and
a
it worked
clock.
just fine.
You have a clock on your wall behind you.
That's correct.
Okay, yeah.
That's correct. So it is 9 in the morning. It is, yeah, 9 in the morning for
Oh,
the
yeah, it's
United
early, yeah. Okay.
And we have
Well,
snow, actually. We've had snow for 2 days.
oh, really?
Yeah.
It's been glorious here. We've had like a little mini summer over the past 2 days, but the temperature's supposed to drop like 40 degrees and be cold again. So,
That's a lot, 40 degrees.
yeah.
Maybe I can, I don't know, maybe I should shut this off, maybe. Can you still
It
hear
is.
me?
Yeah, I can hear you. Yeah.
Okay, good. Maybe I'll shut off the video and not
Sure.
worry about that.
Yeah, it was interesting, but perhaps a little distracting.
Yeah, I know. Yeah, sorry about that.
That's okay. Let's see here. Okay, we are recording, and fewer people than usual, but that's maybe expected because this week we're doing kind of the same stuff as we've done in previous weeks, or as last week. So we're doing a number of things this time, but maybe I'll just wait a minute to see if anyone else pops in before getting started. How you doing, Callie? Good? Okay.
Do you guys see the chat window? I don't
Oh,
know if
yeah.
it shows up on the recording. It's so funny because I teach online. So I teach at an online school and we use chat very extensively during class. And so it's always running and there are always stuff in it. And I go to a lot of Zoom meetings outside of my school and nobody ever uses the chat. I'm like, who's putting in all these?
Okay, yeah. I believe Zoom records the chat. Now, when I learned that with Zoom, I only have so much space, so I've been moving them over to the Intro Astro YouTube channel, and I think we probably lose the chat at that point. But, okay, yeah, so more people are coming. That's good. All right. Hey, everyone.
Hi.
Well, let's get started because we have a bunch of things to cover today. 3 things we're going to do. So this is kind of like a break from our usual, each week we're going to do one lab or a major part of a lab. Last week we did Lab 2. This week we will do the other version of Lab 2, the Stellarium-based version. Last week we did the globes and lights version, which is my preferred version. I think it gives the students a better idea as to what's going on, more of a God's eye perspective of things, because they're external to the Sun-Earth system. But there are drawbacks. You all may not have the lab kits, or maybe you intend to build the lab kits, but you don't have them yet. For kits in your classroom, and so you can't use them. So, or you're working with online students and you don't want to ship these kits around. So we've developed this alternative version based completely on Stellarium. And being Stellarium based, it's a different perspective. It's the ground's eye perspective. Instead of bird's eye view, it's a worm's eye view. And there's some benefits to that because as we were figuring things out historically, we figured it out from here on the ground. So it's kind of interesting in that aspect, though I still personally prefer the other version with the students actually making manual measurements and a physical apparatus and that kind of bird's eye or God's eye perspective. But anyway, the Stellarium version has benefits, so we'll go through that, and I won't go through it in as much detail as last time. So for those who aren't here but are watching the videos after the fact, you'll definitely want to watch the Lab 2 video from last week first, and then at the beginning of this one, we're just going to go through the differences. Hey, Dan.
Hi, late arrival.
That's okay. So we'll start with that. And then the second thing we're going to do today is we're going to go through grading and WebAssign. And I'll show you what's involved there. The labs are, for the most part, auto-graded, but some parts can't be, like short essays and figures and things of that nature. So I'll walk you through that so you can see how it's done. And then in the third part, assuming we have time, I'll show you some of Afterglow 2.0, which we've been working on hard for a couple years and are getting close to finishing. And I really think we'll be switching over for fall of next year. But more on that later. So if there are no questions, does anyone have any questions about anything, putting in observations from the previous labs? Okay, if there's nothing, we'll just jump into the Stellarium version of Lab 2. So let me share my screen. Okay, and let's get rid of this. Go into WebAssign and bring up Stellarium version of Lab 2 from one of the sections. Loading, here we go. And again, feedback from, well, it's gone now. Okay, so again, I'm not going to go through this in great detail because much of it is the same as last time. I'm just going to point out the differences. Same instructions to the top, except it's a different video, introductory instructor video at the top, giving you an example of how an instructor might set this up before it's done. Again, I point out the most important note is always here at the bottom, telling them what observations they need to put in for the next week. Now, if you're doing the Globe and Lights version, at least here at UNC, we do that over the course of 2 weeks, as we talked about last time. And so at the beginning of that first week, we tell the students to go over to Lab 3 and put in their observations. We went through this last time, and they're picking a gas giant, and they're going to take one picture a day of the moons going around the gas giant. Though once we update the labs, it's probably going to be 2 pictures a day since we now have telescopes on both sides of the planet. Anyway, if you're doing the Stellarium-based version, it probably is only a 1-week experience, so you have half as much time to collect that data for Lab 3, but that's okay. As long as they have 5 or 6 or 7 good observations, you really only need 4 or 5 observations to do the lab. If you have 6 or 7, that's good. 14 is overkill, but there can always be periods of cloudiness in particular observatories. Maybe if you're doing the Stellarium version, you want to open it up to more telescopes than just a couple prompt telescopes to ensure that you get enough data for that lab. Okay, moving on down, the goals are the same, except last time we had 4 goals. And the first goal is figuring out which way Earth is rotating counterclockwise as viewed from the top. There's that's not really an important lesson in and of itself, but it was a practical necessity for doing the lab. You needed to know what side of the apparatus you were on, the sunrise side or the sunset side. Since these are done in Stellarium, that doesn't matter anymore, so that section of the lab is gone, but the other 3 sections remain. Equipment's also different. You don't need all that experimental setup. You just need a computer with an internet connection, and of course the Stellarium software, which we use in multiple labs. The first background section, again, is teaching about longitude and latitude, and previously they would then go to the globe and measure this off of the globe for Chapel Hill, since it's Skynet headquarters. But we're not working with globes now, so they're going to do this in Stellarium. And it's very simple in Stellarium. Let me bring Stellarium over here. Now, when you load up Stellarium, I think I'm trying to remember if I mentioned this before. When you first load it up, it fills your screen, and there's nothing to click on easily to minimize it. Function F11 see, it comes up in full screen mode. You're like, how do I shrink this? Function F11 will shrink it, so then you can get it out of the way if you need to. Anyway, to measure the longitude and latitude of a particular location, it's really just looking it up in the database. Stellarium has these 2 tabs that disappear. They're little lock buttons here and here that I like to click just so they're always available to me. And the key things are over on the tab here on the left, the first one being the location window. So I can bring that up, and it's already set to Chapel Hill because I was playing, but it normally comes up as Paris. Let me load that. Just type too quickly. So when you first load it, it comes up as Paris, and then you're going to have to pick your location. Maybe it's an observatory, maybe it's in this lab would be a number of cities. For this test, we're checking out Chapel Hill in the United States. You click on it, and then it will just load up the longitude and latitude here, which the student can then type in. And let's see, latitude first, which is, I think, how it's listed here, so there's no danger of them getting them backwards by mistake. The key thing is southern latitudes and western longitudes have to be entered with a negative sign, and that's written here. And that's important for the auto grader. So in the last lab, they're learning how to read it off the globe. Here, they're learning to read it out of Stellarium, because they're going to be picking a number of cities, as you remember, and they'll need access to that information. Then this background section is exactly the same as before, setting up the question, why is it hotter in summer, colder in winter, defining terms, trying to clarify the misconception that it's not a proximity effect, it's a tilt effect, everything we discussed last time, the same end of section question there. And then we get into the procedure. And again, there are two major effects here. One is the length of day for different seasons and different latitudes, and the other is how high the sun is above the horizon, also for different seasons and latitudes. We start with the practice, and then we do it for many cities. So again, the practice is Chapel Hill, and it's going to be a little bit different here because they don't have a globe. They're not trying to line their city up on the Terminator and measure times using the hour circle at the top. It's all in Stellarium. I'm going to move the instructions off to my other monitor to remind myself if I forget, and do it over here. So let's see. First thing that we want to do is zoom that back out again. So we're already at Chapel Hill. Normally you'll pick your location and get set there. And you'll also be setting your season. So that's the next button down here. In this particular practice, you're figuring out the length of day in Chapel Hill for the summer solstice. And so you go to the summer solstice date, June 21st typically. And then we're going to bring up our object, which is the sun. That's the fourth one down here. I'll bring it up, and it's up there in the sky. And now we have to find the sunrise and sunset times. So again, we use the date and time feature here. I'm lowering the hours. Thought it was. Yep, here we go. Lowering the hours. Something. What's going on? That is weird. When I went to, oh, I'm changing the months. That's my problem. 1 second. I go back to June. Okay. Hours. Okay, there we go. Sorry about that. Okay, changing the hours to the sunrise location. And when you get close to sunrise, and particularly if I go a little bit lower, you can no longer see the sun. And so it's a kind of a difficult measurement to make. Basically, you're just seeing the glow of the sun. And so what I tell students to do is get a little bit above the horizon. And as we've set it up here, the sun will always be at the center. So what I'm doing right now, you can't see it, is I'm taking my finger and putting it on my screen right at the location of the sun. And then I'm making the sun set. And although I won't be able to see the sun very well in all the glow, I can see my finger. I'm going to make my finger halfway up and halfway down above the horizon, the natural horizon. I can ignore the trees or buildings or things in the way, try to estimate the natural horizon. So, here we are at 6:03 a.m. That's the sunrise time. And you convert that to a decimal hour as before, and we put that in here. And you can then also do the sunset time.
So Dan,
Yes.
So you don't have them turn off the atmosphere and trying to get it real accurate, or is there
I
do it
don't.
later on? Uh-huh.
Now, so this is something you can choose to do. If you want them to go for like extreme precision, you can get rid of the atmosphere. You can get rid of obstructions on the horizon. Stellarium has lots of options. You can pick a sea view, and so you have a perfect horizon. You can do that. I've chosen, as I've written the lab, you can do it however you want, but as I've written it, I've chosen to make it more of a real world experience.
Yeah, that's fair. Okay, thanks.
And the auto grader, it is generous, but the times that I, for like this test problem here, I have the atmosphere. You can turn the atmosphere off and things like that, but I kept it all in there, so it's the actual length of day you would measure. Okay, and for like this one here, again, the finger really helps. Again, I'm holding my finger here because you have lots of obstructions, the tree and the building and distant mountains. And so I'm getting right around there. Again, you can't see my finger, but my finger is half above, half below the natural horizon. So there you have a sunset time, and you can just subtract the two. Okay, so that's the difference there. Then, as you remember from last time, we have them pick a number of different locations on Earth. One just a little bit below the Arctic Circle, one part way up in the northern hemisphere, one near the equator, one part way in the southern hemisphere, and one near the Antarctic Circle, but just a little bit above it. And they'll go into Stellarium, and for each city, they can read off the latitude that goes here. So they list their cities as before from north to south because the autograder is expecting them in that order. Again, the autograder is very generous. It's taking a very generous range of latitudes, and it knows how long the day should be for everything in that range. So as long as you list them from north to south, you'll be okay there. One thing I've noticed is it's very hard to find that final southern city, something just slightly above the Antarctic Circle, and so they may have to add one. And there are instructions here on how to add one, but I'll just show you. So I'm going to go back to the location window, and what I found is what I like to use, there's this little island, maybe it's hard to see over the screencast, but right in this little dip here, this little nook, there's a little island called Biscoe Island. And so you click on it, you name it, and you may want to change it just for catalog purposes to Antarctica, because it's not in the United States. And I guess when I did that, it erased the name. So you may have to do it again. Biscoe Island, and then you can add it to the list. I won't click there because I've already added it to my list. So if I click on what I've added, it sends me to that location. But your students may have to add it. There are a few other possibilities. That's just one that I suggest. Okay, but otherwise, then they go through that same procedure, measuring sunrise times and sunset times, and the difference is the length of day. Now, sometimes depending on the time zone settings in Stellarium, you may cross the date line, and so you have to be a little bit careful when determining the length of day, depending on what cities they pick and what time zone their computer time is in. Okay, and then the rest is the same. They're going to go to the same graphing website to plot their curves. We're in answer key mode, so they don't see this. These are measurements that I made off the globe. Doing it off Stellarium, they should be more precise, so you should notice even less random variation in there. Then the other big difference is measuring the height of the sun at midday. And again, we're going to practice with Chapel Hill. So let me move this over, and I'm going to put our location back to Chapel. Anyway, go. Close out and back up. It's only giving me Antarctic cities. I have to change this to the, let me click on the US. See if that helps. Oh, I'm typing in the wrong area. Maybe that's the problem. I'm actually going to have to change the country back to the US. And let's try again. Chapel, there we are. Chapel Hill, United States. Okay. And again, we're looking at, for this practice problem, it is summer solstice, so we're good there. And what we want now is the sun being as high in the sky as possible. So if I move the time back a little bit, we see it go up. And when we do this, you see you lose your perspective. You don't have the horizon anymore, so you may have to zoom out. You should zoom out. And I like to zoom out, and you have this fisheye effect. I like to put south at the bottom. You don't have to. And you can do it by eye, but you can also be more precise about this because they have the numerical values over here. Now, sometimes it may be hard to read. They're in black. If I zoom a little bit bigger, I can see the numbers. Or if you want to stay in this kind of mode where it's superimposed on the grass, there's a night vision button down here. It's the little eye symbol with the star. And that can make the words and the numbers a little bit more readable. So let's see. We're looking for altitude. That's this number right here. Sometimes you may want to stop the clock so you don't have to watch the numbers moving so much. So it's this number here. And as I change the time, that goes up. It's up to 71, 72, 73, 6, 77, still going up, 78, 9. Let's see this here. I'm looking at the right one here.
Could you point out which number you're looking at again? The
it's the altitude here.
Altitude, yeah, gotcha.
And I'm just trying to make it as high as possible. 8, 9, 80, 92. I'm going over the setting position. Something is coming back down. I must have something wrong with my time zone. Sorry for the confusion here. System default. It's custom time zone. I'm going to exit and re-enter.
And
yes.
Your issue is you have daylight savings start on.
Okay.
I ran into this issue when I was writing a lab last week.
Okay. I've never had that problem before, though I've always been able to search on Chapel Hill again after setting up the site in Antarctica. Let me just try. Chapel Hill. Okay, I'm in Chapel Hill.
Dan, the screen's black.
For you?
Yes.
Yeah, black for me too, Dan.
Okay. Function F11. Is it there now?
Yeah.
Yes, it is that. Thanks.
Okay. When it was in full screen, I guess that was the problem. Okay. And I'm going to search on the sun. Oh, you know, I think that might have been, that was the problem. I wasn't on the sun. I remembered that I was on some object over here. I had somehow gotten off the sun. I think that was.
Oh, that's right.
problem.
You were on like Castor or Pollux or something.
Yeah, that's
right.
it.
Yeah.
Yep, you got to be back on the sun. Yeah, I don't think the time zone or anything will matter. Where is it here? This number right here is what I'm going for. And oh, I got to also get back. We're doing summer solstice. So let me set that back up again. Okay. Should be okay now. Okay. So it's going down. If I go in this direction, I'm at 73, 74. 75, 76, 77. Okay, there's the max right there. And again, I can stop the clock. I can zoom out a little bit, and south and southern sky. So there we go. That's as high as it gets. So it's actually pretty easy to do, despite the difficulty I just had. I wasn't clicked on the right object. That was my problem. Anyway, so here's the lab again. And so they'll input that here. It says to round it off to the nearest degree. So that's 78 degrees. And then just like last time, they're going to pick a handful of different cities. They're going to pick the North Pole as one location, something near the Arctic Circle, something between the Arctic Circle and Tropic of Cancer, and something near the Tropic of Cancer. And again, they get their latitudes, as we talked about before. They enter them here from north to south. And for different seasons, they're going to measure the height of the sun above the horizon at midday. And again, for winter solstice, at the North Pole, the sun's below, the highest it gets is well below the horizon, so we just give them minus 23.4 is the number to use in their plots. And again, they'll go back to the graphing website, make a plot just like last week. And again, we're in answer key mode, and those are measurements I took using the globe. Using Stellarium, they should be much more precise. In fact, when they did their practice problem, we don't even have them calculate a % error for these like we did in the previous lab, because as they're measuring it, they're getting it pretty much exact. So there's no point in calculating a % error. And then the final part of the lab is the same. Remember, this final part, we're setting up the cosmic distance ladder. We're measuring the size of the Earth by measuring the height of the sun at midday at 2 locations at different latitudes, but essentially the same longitude. We're envisioning this road trip from Winnipeg, Canada to Omaha, Nebraska. And the only difference is they're not using the protractor and string, but they're going to measure the height of the sun at midday at these 2 locations in Stellarium to get their angles. And it doesn't even matter what season they use. The difference goes here, and then they can continue to do the rest of the calculation as before. So those are the differences. A slightly different perspective. It's the ground's eye view. There are certain pluses to that, but I think the primary plus of this lab is it's useful for the online students, or if you don't have the lab kits yet. Okay, any questions about that? All right. Next.
Wait, sorry, very quick.
Yeah, go ahead.
So would it be really hard to have WebAssign grade it such that like the students could pick the start and end of the road trip instead of having Winnipeg to Nebraska? Or I'm guessing it would. And also for the WebAssign, like letting them pick their own location to find the altitude of the sun?
So you're basically saying, can they pick their own cities? Yeah, I think so. I'll make a note of that, because as I've said before, I'm about to go through and do lots of updates to these labs as Afterglow 2.0 is released, and that's definitely something I can look into.
Cool.
And you can always do it. It just you have to make if you don't give them if they're picking the cities, then we'll have to loosen up the auto grading, because I don't think I can give WebAssign like a lookup table. Though what we could do is have them enter the longitudes and latitudes as well, and then base the auto grading on that.
Oh, interesting idea.
Yeah. So I'll ponder that, and when I get to redoing this lab, and if I do it here, I'll do it in the Globe and Light version too. I'll figure it out.
Dan, as a quick question, so there's been a couple of things I wouldn't mind adding to this lab. On my end, I haven't thought it through yet, but is there a way that we can add stuff to your lab?
So a couple things. One, you can suggest it to me, and I can implement it for everyone. If I think it's a good idea and if it's going to work for a large, broad audience, I'm happy to expand on these. Or if I have something in any of these labs that you think is a waste of time, let me know as well, and I can decrease the size of them. So that's kind of like the hardest way. The other way is in WebAssign, you can create assignments to go with this. Yeah, so you could add like a little supplemental homework assignment. They're very simple to design.
Okay.
An elaborate lab like this with the accordion functionality is beyond the toolkit that they give the average user, but if you're doing basic questions like multiple choice or simple calculation, you can build those yourself.
Okay. Thank you.
And the other thing I should note is these instructions at the top, they're editable. The rest of the lab isn't, but you can add things up here. There's no auto grading up here, but you can add other instructions saying do this and then go and do this other homework. All right, that's that. Next is grading. So I think I can get rid of that. I'm going to keep Stellarium, bring that down. Now let's see, I'll show you. So there are a couple things. One thing is we have this grading guide. And after we get the video put on YouTube and I send that around, I'll send a link to this grading guide. You don't have to use my grading guide. You can go in and change how much different things are worth in WebAssign. But as once you sign up and you get it, it has kind of a default number of points. And this grading guide is suggestion, because I have many different TAs. They're all young. They maybe have never taught before or graded before. There could be wide variation in how they do the grading. So I try to create a little bit of uniformity here. So it's suggestions. That said, many things are auto-graded, which is great. It allows this to scale to very large classrooms. But some things can't be auto-graded, like short essays or the plots. Did they do their plot correctly? Maybe you want to check their moon identifications, things like that. So I have little tips in here of how I instruct my TAs to assign the points. And I'll go through this and I'll give you an example. But again, you don't have to use this. Most people find it very helpful. And particularly if you haven't graded for a year and you're trying to get back into it, and this quickly reminds you, oh yeah, this is how I can go about doing this efficiently. So it's just a Google Doc and that'll be made available to you. Now let's see. I can't violate FERPA. So what I want to do is I want to open up one of these and we'll look at it, but if it's a student, that's FERPA violation. But what I do have, I have a forced certificate version of this course that we just run. There are no due dates. People just do it at their own pace. And they're not official students or anything. It's just a public program. So I can go in there. So let me go down here. Be at the bottom because it's been there for years. And we can expose one of them. So let's see. Here we go. Lab 1, the scores. And so we see them here. I noticed this morning. A lot of these names have been replaced with alphanumerical keys. I'm not too sure what that's about. I've only seen it in this particular section, but this section's been live for like 10 years. So it could be after a certain amount of time, some of these, WebAssign as a company has been sold to Cengage, and maybe some of the older stuff in the database has been lost and replaced with these alphanumeric keys. So let me find a student, maybe one with a name that did well. Craig Bowers. Okay, he did well. So, okay, you go into the score section, and then up here under grade answers, you can either grade all the questions or some subset. Now these labs, most of them are built into a single question. WebAssign, as they define things, just views it as a single question, and it has a whole bunch of subparts, but it's a single question. In Lab 1 and I think also Lab 8, it was too long, and they broke it up into 2 separate question sections. In Lab 1, the first question is all background. There's actually nothing submitted. So we'll just jump straight to the second question, and we'll hit Start Grading. And when I started working with them, they didn't have this, and grading was very difficult, and they built this grading scheme tool in part because of our lab course to make it work better. So now we're in, yeah, go ahead.
Share your screen just so we can follow along. Thanks.
I'm really terrible about that. So if I start talking and I'm pointing to something, I've just forgotten to share my screen. So always remind me of that. Let me back out a little bit just so you saw where I was before. Sorry, I had a low sleep night. I'm working on some stuff, so I'm a little out of it today. But what we did here is I went down to my for certificate section, Lab 1, scores. Loading. Yes, I didn't press. Let me try again. Of course, when you're demoing something. Okay. And those are those alphanumerical things that I was mentioning. I've chosen this student here. He's the one that we're going to look at. But you go to grade answers, and we're picking the second question because that's where all the scoreable parts are for this particular lab. Start grading, and it dumps you off on the first student. And so now you can see what they submitted. Now this first student didn't do anything. In the 4-certificate course, a lot of people sign up but don't actually do it. So I'm going to hop down to the student that we selected, Craig Bowers. It's loading up his work. Okay. And so we're in answer key mode, but you can also see their answers now. So in the first part here, this is where they were imaging the planets and then zooming in and changing the brightness and contrast to make it nicely observable. And then you can add, or you can click on the link to see what they submit. So that's not bad. I would have zoomed in a little bit more, but good picture of Venus and its phases. Mars, let's see how he did here. Oh, that's really nice. That's a good one. Again, I would zoom in to fill the whole thing, but I wouldn't penalize him for this. You can see the ice cap there. He also got Jupiter. Again, really crisp, but I would have zoomed in. Maybe let's look at one more. Saturn, okay? Now the grading guide, I guess you didn't see it because I wasn't sharing, but again, it's this Google Doc, and all the different labs or tabs here, and it just lists the things that you have to grade, the parts that are not auto-graded. Then section PB1, those are these first set of images. It says I'm going to give up to 3 points per detected object. There's a little note there that Mercury, they probably aren't going to get Mercury. It's almost always too close to the sun to observe. And then little notes like subtract a point if they forgot to zoom in, like if it's this big black field with a tiny dot at the center, that's not very useful. They should have zoomed in. They needed to set the contrast to min-max so you can see the detail on the planet. Otherwise, you'll just see the sky glow. Subtract a point if it's streaked because they could have resubmitted. And I also point out some students may pull out an extra object or two, maybe out of twilight, or they adjusted their settings so they were able to get an extra object or two. And how you treat that's up to you. If they did the extra work to pull out an extra object, I give them points for that as well. And then in the lab, the next thing they were asked to do is to write up a description of the detail that they see in their observations. This student did a very good job. In fact, I've never seen this much. He's written a detailed paragraph for each object. I'm really just looking for a sentence or two in the answer key. You can see how I would have answered the questions much more tersely. But so this looks really good. And I basically give them a point. No, it's 3 points per object and to use the key. Then the next thing's in section PB2. That's this table down here. And this is where they're saying which objects they actually got an observation on, what telescope they used, the system date and time, and they measured the angular diameter. This is stuff we went over a couple of weeks ago. And so what the grading guide suggests is 10 points total, 5 points if they fill in the telescope and date and time fields for the observable objects, and then 5 points if they got all the angular sizes in the acceptable range. And so you can see here, this particular student got check marks for all the measured sizes. And all this is doing is it takes an object like Jupiter. He measured 30 arc seconds, and it's actually not checking at this particular time. It just is checking, is this between the smallest Jupiter ever gets and the biggest Jupiter ever gets. And there are buffers built on for atmospheric blurring. It's a very, very generous check. And then I just I see he got 6 out of 6 check marks, so I give him 5 points for that and 5 points for filling in that information, and I type that in here. And this is the part where they were signing their name. They thought it was some kind of honor pledge, but really I just have that in there to give you a place to do the scores. Now, in many of the other labs, the tables will grade, not just put up check marks, but actually do the scores all by themselves. I don't in this lab because I never know what objects are observable. It changes from semester to semester, and institution to institution. You may be doing the labs at different times in the semester. So that part, it does check automatically, but assigning the score, I leave that to you manually for this case. Because they could then cheat the system by saying I observed everything when not everything was observable. Okay, and question.
Do you ever have students who do that, who say they observed an object that's not currently observable?
Sure. I mean, we have 500 students a semester at UNC, so you see everything that you can imagine seeing.
Do you deduct for that?
As we have it set up, the TAs do the grading, and I don't have a contingency for that. I mean, technically that's lying. That could be an honor code violation. Right now we just give them 0 for that. Or maybe they grabbed an image off the sample directory. I don't see that hardly at all. And the ones where it can be a serious offense, I will write demo on the image in the sample directory. Now, one thing I do see is sometimes a student will start and drop out and come back the next semester and use their images from the previous semester, and that's fine by me.
Mm-hmm. Cool.
And we may have the TA give them a talking to, saying, don't try a stunt like that again. The next table here, this is where they look up the true diameter in Stellarium and calculate a percent error. So again, this student, I picked one with a high score, so clearly a good student. Got all these right, though he did do one miscalculation. This percent error is miscalculated. Before we started, I looked up a student who wasn't as good to give you an example of something else. So here's one from another student. Got some things right, but mismeasured Ceres, mismeasured Jupiter. And so you can see Stellarium will give you an X and say it's too high or too low. And then there's this thing called the calculator. Calculator errors, this is something in WebAssign where it means they did the calculation correctly, but based upon inputs that were wrong. And so that's a nice thing to have, except WebAssign counts that as no points. And I would count that as full credit. And other people would count it as something in between. And I've been talking with WebAssign to try to get them to give us that flexibility. And if they did the calculation right, I've already penalized them for measuring it incorrectly. So I don't want to penalize them again for the calculation. At least they do mark that as a separate thing, so you can treat that as you want. Now for this part here, since we don't know if all the planets are observable, again, you're counting up check marks and distributing the points. Like this is worth 10 points. So I figure out what fraction of these were check marks or calculators, because I count the calculators, and then that fraction of 10 points is what I assign. But in other labs where it's just fully auto-grading, if they get a calculator, they'll get no points for that. And so I have my TAs go through, and if they're calculators, they can add the points back in. All the labs have little sections like this where they've signed their name, so a place for you to add points, and you can just add them in there if you want. Hopefully WebAssign will give us more flexibility in the future, but I've been trying to get them to do that for some time. Other things, like here's a place where they're doing a percent error sample calculation, and in the grading guide, I give my TAs different things that would be acceptable and things that are not. So like sometimes they forget their parentheses, and so they'll miscalculate for that reason, so they could lose a point there. Sometimes they forget to multiply by 100. Sometimes they forget the absolute value, and so they come up with a negative percent error. And so those are things that I might subtract a point out of the 3 points for. I never, if they I never keep subtracting things and give them negative points for something. If they've lost all their points through a comedy of errors, I don't go negative. I stop at 0. And sources of error. This one, if you remember, was a discussion about atmospheric blurring. And the grading guide says give them a point if they mention atmospheric blurring. Give them a point if they can describe why the percent error is big on the small objects and small on the big objects. Because atmospheric blurring is a small fraction of Jupiter, but it's a huge, it's much bigger than the size of Ceres. And so you get that trend that the small objects have bigger percent errors. And then the third thing I say, give them a point for here, this last source of error. It's hard to identify the edge of the object. It's some level of grayscale. It's pixelated. So again, these are just recommendations. But that way you don't have to think through it from scratch. It's a starting point. Moon identification. Some people don't bother to check. I have my TAs check. So let's do one of these here. The students, let's do the tough one, Uranus here. So you can click here. What I have below here is kind of the sample. This is what the student actually submitted. So here's Uranus. The student adjusted the brightness and contrast to pull out a few extra moons close to Uranus that would have been lost in sky glow, and has identified them as such. Now what I like to do is I just have Stellarium open in the other window, or the other screen. Lock these in here and maybe go back to normal viewing. And since these images can be taken from all over the world, I don't like messing around with changing the location. I'll just hide the ground and I'll hide the sun. So it's night everywhere. And I'm going to type in Uranus, and it's going to take me there. But also I have to get the date and time correct. And so this student did this observation in 2018, September 5th. Hard time here. There we go, September 5th, 1334. So then we'll zoom into Uranus here. And you may remember from before, there's this little telescope symbol that will put in equatorial coordinates. So that will make the image match up with their image, though there could be a flip. Always keep that in mind, there could be a flip, and you may have to do that mentally. And so they said Titania, Ariel, Umbriel, Oberon, and so they got that right. Now if you look at this carefully, it doesn't match up exactly. I think they got all the moons right, but kind of the positioning, it's a little bit skewed. These are a little bit more off to the right. Oberon's a little bit lower. And probably what's going on here is this user, for certificate program, I have users all over the world. This user is probably based in Europe. So I may have to adjust the time here. If I subtract off 4 or 5 hours, then it looks a lot closer to the positioning. Maybe I went the wrong way. Maybe they're not Europe, maybe they're subtracted off time. Anyway, when I rewrite the lab, I'm going to do this in universal time. It's all in system time because originally Stellarium would only give you system time. They didn't give you the universal. And now it gives you that option. So I'm probably going to swap it over to something more concrete. But anyway, if it doesn't quite match up, just fiddle by a few hours and it'll probably be fine for now. So in that case, according to the guide, I would give them, let's see what I recommend. For the image, I give them 3 points, kind of for the standard stuff. Did they zoom in? Did they put the brightness and contrast on Z scale, blurring out the planet, but so you can see the moons? Did they adjust it so they can see the moons? And then under moon identifications, I subtract points if they got some of the IDs incorrect. And things of the, let's see, use Stellarium to identify, subtract a point if they incorrectly ID'd, subtract a point if they missed a moon, 0 points if the date and time are wrong. If they put in some date and time and you cannot replicate their image, then I wouldn't give them credit for that. But again, you can treat that as you want to. And some people don't grade this, they just let it be. It is a little bit time consuming, but if you have a second monitor and you have Stellarium over in the second monitor, you can zip through these really quickly. And again, I'm not going to do this for every lab. I'm just doing this in detail for this one lab. Down here, there's a part where it asks you to ask the student to just look up each of the moons and write down a fact, so just a simple sentence. And as long as they have a fact for each of the moons that were actually there, I give them credit for it. The last two parts of the lab, one is moon identification, one is the deep sky objects. So under moon identification, let's see how this student did. They did Pluto. So there are two images that they're submitting. There's their image and the DSS image. And the grading guide says 1 point for the correct field, 1 point for marked reference stars, 1 point for marked and plausible dwarf planet ID. I'm not too hard of a grader because these are hard to do, particularly with the online students where they have less of an opportunity to ask for help. So this is the image they got. They think this one here is Pluto. They didn't mark any reference stars, so they would lose a point for that. That means it's more work for us as the grader to figure out, is this actually right? Here's the DSS image, and if I blink between them, at least I already can do the alignment because I'm good at this. And yeah, the object they marked is not in the DSS image, but really what they should have done is marked the same reference images in both and zoomed into this region to make it really easy for the grader. Then yeah, I see stars A, B, C, and D that they marked in both images, and yeah, there's this extra thing here they label Pluto that's in the one that's not in the other. The only downside here with WebAssign is they only let you view one at a time. So sometimes I have to do a screen capture and put it to the side and load up the other one. And then the question? Okay, the final part is just we had them pick a nebula and image it in just the brightness and contrast until it looked good. A globular cluster, that looks good. And a galaxy, looks good. And so for those, it's pretty straightforward. As long as they did it, they get 2 points. And then they're gonna look up a fact about each. Again, each one is worth a point. So that's an example how to grade lab 1. My experience with grading is it gets easier from lab to lab to lab. Now lab 1, remember, is not very scientific. They're learning how to use Skynet, how to use Afterglow. It's an exploration, and not all the targets are always visible, which puts a little bit more burden on you as the grader. But as you go from lab to lab, the more of it can be auto-graded, the easier it gets, as we'll see. Anyway, I'm not going to go through the grading of all the other labs. I just want to give you an example of that. So questions about grading before I show you some Afterglow 2.0. I think it's a pretty nice grading interface that they built, except for that issue with the calculators. And of course, there's, if we go back to this screen here, there are lots of opportunities to go in and override a grade, add bonus points, things of that nature that we often have to do as a matter of course based on circumstances. Okay, last bit for today is demoing Afterglow 2.0. So far we've been looking at 1.0, and hopefully again 2.0 will be ready come the fall. So if you want to play with 2.0, let me just back out. The 1.0 is under skynet.unc.edu/afterglow. 2.0 is under afterglow.skynet.unc.edu. Now I'll put the link in the email after the fact, and it's accessible now. You can use it, and it's linked to your Skynet account, and so you can bring up your images. So I'll go there, and if you're not logged in, there's a little button saying log in through Skynet. It'll take you to the Skynet page, log in, enter your stuff, and then it puts you in here. I already have some stuff loaded up, but originally this would be blank. You have a workbench, you have data providers. There'll probably be some other things in time. Let's go to data providers. These are ways to get data into the system. You can use Skynet. So if I go here, I can see collaboration observations, group observations.
We don't see your screen.
Yeah, screen share maybe.
Thank you. Thank you. Again, I said I always forget to do this, so always remind me. I'm going to back out again just so you see what you missed. It's afterglow.skynet.unc.edu, and you type that, and it'll bring you up to a page where you can log in. I'm already logged in. You'll log in with your Skynet credentials. Then you're here. Data providers. So we have the same sample directory that's currently in Afterglow 1, plus some other things, I think. Here's the Skynet directory. So these are links to your observations, but there are going to be other things as well. You're going to be able to upload images, non-Skynet images, into the system. And
That
also
would be great. Yeah,
Yep.
that would be great.
That's built into 2.0. We're going to support that. And also, you'll be able to access catalogs. Digital Sky Survey, Sloan Sky Survey, all sorts of catalogs. You'll be able to bring in those images, Hubble databases, whatever we want to come up with.
Gaia?
Yeah, it's all going to be there. And but right now, we only have these two set up. So maybe I'll go to sample here, Deep Sky Object. Oops, I double-clicked early. You can pick one. I don't know. Let's pick the Southern Pinwheel. That's usually pretty. And import it. And it will come up. Here it is. I guess the list is down here. And see how it did really quick, but you saw it loaded bit by bit by bit by bit. This is designed to work for large format images. Afterglow 1.0 has a maximum size. That's why I've limited your telescope access just to the telescopes with small format cameras. Once 2.0 is ready, your students will have access to everything on the system. The moon is a good one here because you can see it load there. This is a very large format image, so you saw it load piece by piece, but it did so pretty quickly there. Okay, so things to show. I'll probably go about 5 minutes over today. And more is being added. Right now, my programmers are busy building in field calibration technology. So you'll be able to bring in an image and very easily tie it to a catalog of stars with known brightnesses. And then after that, we're going to expand on our photometry stuff and plotting light curves and whatnot. But I'll show you what's in here right now. So this is basically histogram scaling. Let me bring up this. This is a faint galaxy. So I can go to bright mode and just see the brightest objects. I can go to faint mode that brings this out. Here I'm back at the default. And I can also alter this by sliding the up and bottom. This is maybe not the best image. Let me see, maybe Saturn. It's again a Google Maps feel. You can zoom in. This is a bright target, so that kind of helps. And you can change it by playing here. We may add a little bit more fine-grained control. So if you're trying to bring out something faint, let's go to the tarantula and fit it to the screen there. If I want to go faint, I may want to adjust this, and you can see it's a very fine control here because I'm not moving this red bar too much. And so we'll probably modify that a little bit. You have other options. You can have color maps that we couldn't have before, different scalings. Instead of linear, you can square root, arc sine, stuff that you find in DS9, logarithmic scaling. So those are some new additions as well. Also, you can flip, you can rotate images, things of that nature. There's also a nice sync functionality. So let me load in this galaxy. This is from the Digital Sky Survey. I'll go to split screen mode. And here's an image of the same galaxy that a student observed. It's kind of hard to see in ours, so I'll go to faint mode. But it's the same galaxy. And you have options like syncing. And so then the two work together. I can zoom in simultaneously on both. So lots of nifty things that you'll be able to do because of that. I'll demonstrate one in a second with tracking asteroids. We have these tabs over here. The next tab down is information. It just shows you header information, some of the basics, or you can see the full-blown everything that's in the FITS file, which is more than most students need. Let me find one that may have a little bit more information. So here we have, you know, the size, field of view, start time, stop time, telescope, basic information there. Here we have the marking functionality. Let me go to just one of these right now. And so this works a lot like in Afterglow 1.0. You can double click and it puts up a marker. You can change the label. You can change sizes of things. Make the marker bigger. Change the gap. Change the angle. The label's presented. It took a lot of work, but you can then rotate the image and the label will stay in the same relative location. So if you get it, if it's a crowded field, you put your marker, your label such that it's not over top of any stars, and you start to adjust the rotation, it will still stay not on top of the stars. And you can also print, save things here. So there's a camera shot and it will save it to a JPEG. So you can grab things very easily. There's that. Cross-section functionality that we don't have in the other one. So you can do cross-section. Let me find something more interesting, maybe Saturn. Do a cross-section across that. And you have like an interpolation mode that can smooth it out. You can have the option to centroid your clicks. So if you're clicking on a star, it will auto-centroid the click or not, or planet centroid. Because this is also the same as the measuring tool that we've seen in Afterglow. Let me bring up, I wonder if I can see the moons in this image. I get a faint mode, yeah. So if you want to measure the distance between Saturn and that moon, which we'll see a lot of in Lab 3, I can switch to planet censoring. You can see I'm not on the center of Saturn, but if I click, sorry, I'm in the wrong part here. If I click, it went right to the center. And if I click here a little bit off center, it missed. Maybe I had to be a little bit closer. Oh, it's on planet center. But anyway, little niceties like that that we don't have in Afterglow 1.0. I'll skip sonification for a second, go to the current state of photometry. And I have a sequence of images here of an asteroid called Cleopatra. Go split screen mode. And probably move the split screen up to the bar here so it's always available. We don't have to jump to this one place to find it. And let me sync the two images. One second. This is the first one. This is the second Cleopatra. Sync. Okay, so now they go together. And if I go to the photometry window here, now I can start marking objects that I see. And you can see a lot of these are in both images, but some of them are in one image and not the other, and so that's going to be our moving asteroid. And so here's a fun thing you can do. You can say, okay, these are really the same object. I'm going to merge them. Now it's a moving object, and it's figured out its motion. So if I load any of these intermediate ones, it knows where it's at. And so this is good if you want to do like a light curve of a moving asteroid, because it's going to photometer this moving location. And it does more than just linear, it does quadratic interpolation. You can do this for extended time. And then select all the objects you're interested in photometering. And photometer the selected, and it's created a job that went to the server. It took about a second, it's done, and you can download it right now to an Excel file. But as you'll learn in Afterglow 1.0, we have graphing tools built in, and we will be building those into 2.0 as well. So you can graph this stuff within the application. But right now, just dump it into Excel. And then kind of the final cool thing I want to show is a lot of our grants are based around getting feedback from somebody. Test, test. No, one of you needs to mute, I'm afraid. And just start muting. Okay, I got one. There's one of you, I got you. Yeah, so Skynet and Afterglow, a lot of the funding is coming to make this accessible to blind and visually impaired students. So we've been investing some preliminary study into sonification. Let me get rid of one of these windows here. And so we can sonify images. Let me start with the globular cluster. Make it easy to see. And I'm going to unplug speakers, and hopefully you'll be able to hear it. Go back to sonification. And there are different things you can do to zoom into different areas. Because remember, blind students can't use mice. They have to do tab-based things. But I'll just zoom in there, and I'll sonify. You can, in just a second, hear what a globular cluster sounds like. Now explain it. So the way to think about this is imagine a piano running across the image, and then with time we move that bar, that piano, up. So stuff on the left plays low notes, stuff on the right plays high notes. Eventually with color images we'll have different instruments like tubas and flutes for red and blue, or different sonic effects of that type. And it also works well with earphones because we do it in stereo. The left of the image comes in the left ear, the right of the image comes in the right ear. And we've tested this with students, and like a globular cluster, it sounds all kind of plinky. Though if I were to play something like the moon here, I'll sonify that. We're hearing nothing right now, but you can see it. Given the curvature here, they can probably figure out the contour of the moon, and they have in our studies. And maybe I'll show one more just for fun. Here's one with the satellite running through the image. Maybe just the brightness and contrast. So you can see the satellite. So there's a big bright star in the lower left, so initially we'll hear a loud low tone. This galaxy is actually kind of faint. You may hear some fuzzy in the middle, some fuzz in the middle of the spectrum, but then you can imagine what the satellite moving across will sound like. Or the boom, the shh, and then whoop, going up the keyboard there. So this is still a work in progress, but we have been testing it with BVI students, and after getting trained on what the sounds mean, they can actually then describe the image in some detail. So it's interesting, and we'll continue to explore these kinds of technologies. Anyway, I've gone about 6 minutes over. I'll go back from sharing the screen, and any final questions? Okay, so next week we're back to Skynet-based labs, Lab 3. Hopefully some of you have gone in and have already been collecting your data. Jupiter is really the only gas giant that's good right now. If you haven't and you want to, go in, and we described it at the beginning of the last video, and you can put in observations of Jupiter, collecting them once a day or twice a day if you want, and then we can make some movies and plot some orbits and use Kepler's third to figure out Newton's form of Kepler's third to figure out masses of central bodies. We'll also be doing some phase stuff with the Venus to determine heliocentric versus geocentric. All right, I'll see you all later.
Thanks, Dan. Bye.